Hello guys, welcome to Apex Math. My name is Bino. In this video, we go through question 1 from the April 2025 N6 Mathematics question paper. Question 1.1, we calculate the equation of the tangent to the curve given by the parametric equations x is equal to 3 sin t and y is equal to 2 cos t at the point t is equal to pi divided by 4. The equation that we are going to calculate is not going to be in the form of t. It's going to be in the form y is equals to mx plus c, and we have to determine the gradient m using differentiation. So we don't have the m, and we have to determine the value of y and determine the value of x, which will help us determine the value of c. To determine our x, we are going to substitute the pi over 4 where there is the t, and also to determine the y, we substitute the pi over 4 where there is that t. So we have y is equals to 2 multiplied by the cos of pi divided by 4, and our x will be equals to 3 multiplied by the sign. In the place of the t, we substitute the pi divided by 4, and our x will be equal to 3 multiplied by the sign. So in the place of the pi, we can substitute 180 degrees if our calculator is not in radians. So we'll have 180 divided by 4. And to determine y, in the place of the pi, we substitute 180 degrees since pi is equal to 180 degrees. If your calculator is in radians, you have to work with the pi, not the 180 degrees. So we are going to have y is equals to 2 multiplied by the cos of 180 degrees divided by 4, which is equal to the square root of 2 divided by 2. And our y will be equal to the square root of 2, because that 2 and that 2 will cancel out and we'll be left with the square root of 2. On the other side, we have x is equal to 3 multiplied by the sine of 180 divided by 4, which is equal to the square root of 2 divided by 2. And our x, we just leave it as 3 multiplied by the square root of 2 divided by 2. Now we have the value of x and y. Our x is 3 times the square root of 2 divided by 2, and our y coordinate is equal to the square root of 2. And this will be our x and y coordinates at the point of tangency. We have successfully determined the y coordinate at the point of tangency and the x coordinate. Now we determine the gradient using the methods of differentiation. We copy and paste the parametric equations. We have the following parametric equations, and our gradient m will be equals to the derivative of y with respect to the derivative of x, which will be equals to the derivative of the y with respect to t divided by the derivative of the x with respect to the derivative of the t. From the two parametric equations, we determine the derivative of the y with respect to the derivative of the t, and this will be equal to the 2 multiplied by the derivative of the cos, which is negative sine of t, and the derivative of the x with respect to the derivative of the t will be equal to 3 multiplied by the derivative of sine t, which is cos of t. So the dy divided by the dx will be equals to the derivative of the y with respect to t divided by the derivative of the x with respect to t. We already determined the dy divided by dt as negative 2 sine t and the dx divided by dt as 3 multiplied by the cos of t. So let's substitute. In the numerator, we have negative 2 multiplied by sine t. In the denominator, we have 3 multiplied by the cos of t. At this point, you can substitute the pi over 4 where there is t, or we can simplify. So we have dy divided by dx equals to negative 2 divided by the 3. The sine t divided by the cos t will be equals to the tan of t. Now we can substitute the pi divided by 4, so our m will be the dy divided by dx at a point pi over 4 equal negative 2 divided by 3 multiplied by the tan of t, but our t was given as pi divided by 4, the point pi divided by 4. So we substitute the pi divided by 4, and if you are working with degrees and not radians, then in the place of the pi you substitute 180 if your calculator has d at the top and not r. If it has r, you work with the pi, and this will be equal to negative 2 divided by 3, and the tan of 180 divided by 4 is equals to 1. So our gradient m will be equal to negative 2 divided by 3. Now that we have our gradient and 1 point, we are going to have y is equals to mx plus c. We already said that the m is equal to negative 2 divided by 3, and we have that 1 point at the point of tangency. We use this to determine the value of c. Our y-coordinate is equal to the square root of 2, so we substitute the square root of 2 where there is the y, and our m is equal to negative 2 divided by 3, and our x will be is equal to 3 times the square root of 2 divided by 2, and that 2 and that 2 will cancel out, and the 3 and that 3 in the denominator will cancel out, and we'll be left with the square root of 2 equal negative the square root of 2 plus c, and our c will be equals to 2 times the square root of 2. And now that we have our gradient and the value of c, our y will be equals to, in the place of the m, we have negative 2 divided by 3 multiplied by the x, and in the place of the c, we have 2 times the square root of 2, and this will be our equation of the tangent. Question 1.2, we are given the function z is equal to the cos squared 4x minus 5y, which we rewrite as z is equals to, so we remove that square and we put it outside. So we have the cos of 4x minus 5y y raised to the power 2. It becomes easier for us to differentiate when the 2 is outside. So 1.2.1, we have to determine the partial derivative of the z with respect to the partial derivative of the x. So we are going to treat the y inside the cos as a constant. So we differentiate, we have the 2 from the exponent multiplied by the cos of 4x minus 5y. From the exponent, we minus 1. Now we differentiate the inner function. The derivative of the cos is negative the sine of 4x minus 5y, and the derivative of the 4x with respect to x will be 4, and the derivative of the 5y will be 0 since we are differentiating with respect to x. We simplify the partial derivative of the z with respect to x, and we have the 2 multiplied by that 4 multiplied by the negative as negative 8 multiplied by the cos of 4x minus 5y, and 2 minus 1 in the exponent will be 1. We multiply this by the sine of 4x minus 5y, and this will be our 1.2.1. 1.2.2, we have the partial derivative of the z with respect to the partial derivative of y. So we treat the x as a constant, and we differentiate that z. So we have that 2 from the exponent multiplied by the inner function as it is, the cos of 4x minus 5y, and at the exponent we minus 1, so we have 2 minus 1 multiplied by the derivative of the cos inside, which is negative sine of 4x minus 5y, and the derivative of the 4x with respect to y will be 0, and the derivative of the negative 5y with respect to y will be negative 5. So we treat the x as a constant because we are differentiating with respect to y. And now we simplify, so the partial derivative of the z with respect to the partial derivative of the y will be equals to, we have that 2 multiplied by that negative 5 multiplied by that negative, which will be equals to positive 10 multiplied by the cos of 4x minus 5y, and we multiply by the sine of 4x minus 5y. Friends, this will be our answer for question 1.2.2. If you have any questions, you can drop them in the comment section below. Remember to subscribe, like, and share the channel if you find this content useful.